So here's a homework problem that was presented to me for some sort of guidance and help. So the first question is to find out if the function has an inverse. As you know from pre-calculus, if you recall, uh, the notation for inverse is if the function is f of x, is f of x to like a minus 1. This uh, is the inverse notation. Okay, so you're given f of x is equal to x cubed plus 2, and you're asked also given that a is equal to minus 1, which is something that they will ask you about later. So if you're asked to find the inverse of a function, which is this function here, there's a series of steps, okay? First, replace f of x with y. So y is equal to x cubed plus 2, yeah? And then what we do, we interchange x and y. So the next step is interchange x and y, meaning wherever we see y, we write an x, and wherever we see x, we write a y. And then we solve for y. So if we do that, we have x is equal to y cubed plus 2. So we're minus 2 on both sides. So here we have x minus 2 is equal to y cubed. And then to get rid of the cube, we'll take the cube root of both sides. So now we have the cube root of x minus 2 is equal to y. And this is my inverse, okay? So we can replace y with inverse notation. So we have f of x inverse is equal to the cube root of x minus 2. Now, so that's the inverse, right? If you had got a plus or minus here, right, then we'd had a problem where there's no inverse there. So if you go back to your example, right, and you had looked at the graph, okay, so let's do that. The graph of f of x. So if you look briefly at a little sketch of the graph, you should know what x cubed plus 2 looks like. It's the cubic function shifted 2 units up. So your graph looks like this. And if a function passes what is called a horizontal line test, yeah, if at any given point the horizontal line test is passed, yeah, this is called a horizontal line test. Yeah, then that function has an inverse, right? So the function we know does have an inverse. So this is the inverse of that function. And that's now sometimes also, if you notice that you can find an inverse, the inverse doesn't exist for the entire function. But if you restrict the domain, then the inverse can exist. Yeah. So for example, if your function was a parabola, right? Example, if you had f of x equals x squared, obviously the graph of x squared, as you can see, would not pass the horizontal line test, right? If you draw horizontal lines on this graph, it would hit twice. So here it does not pass. Horizontal line test fails. But if you had restricted domain for x greater than 0, then you wouldn't have an entire graph, right? If I restrict the domain, let's say a new function, if f of x is equal to x squared for x greater than 0, then my function would only be half the parabola. And then in this case, the horizontal line test will pass, okay? Okay. So sometimes we restrict the domain to make the function as an inverse on a specific domain. And that's the reason if you look at some of the pre-answers, they give these notation here, right? Now in your scenario, this function does have an inverse. So f is 1 to 1, okay? So this here would be our choice. So the second part, the follow-up, is that use the function f given real number a to find the derivative of the inverse function at a. So let's look at that. So we know what the inverse is, right? The inverse is the function, the cube root of x minus 2. So the second part of the function, f of x inverse, is the cube root of x, we said x minus 2, x minus 2. Or if you want, you can write this as x minus 2 to the 1/3 power. Okay. So the derivative of the inverse, that's the inverse, the derivative of that prime would be, using the power rule, 1/3 x minus 2 to the 1/3 minus 1, and then the derivative of the inside, which is just 1, which is the chain rule. Simplifying this, we have 1/3 to x minus 2 minus 2/3 power. And 1/3 times 1 is the same as 1/3. So this becomes 1/3 to the cube root, if you want to write it as a root, x minus 2 squared. Now they ask you to find the derivative, right, when a is equal to minus 1 in your example, minus 1. So a is equal to minus 1. So f of a inverse, right, inverse prime would be 1/3 times the cube root of minus 1 minus 2 squared, which is 1/3 the cube root of minus 3 squared. Well, this is a squared here, so it doesn't matter if this is positive or negative. So we can write this the same as 1/3 the cube root of 3 squared. or in exponential form, will be 1/3 times 3 to the 2/3 power. So the way pre-format, f to the minus 1 prime a, so f to the minus 1 prime, the derivative of the inverse at a is equal to there should have been a minus because this is minus here. All of this is over 1. Okay. So simplifying this would be 1 over 3 times the cube root of 3 squared. Okay. So this will be the derivative of that. And keep in mind that this is a times here, right? So I don't want to make sure it's not in the denominator. That's a times. So this would be the results for that particular question. Now they did say in your hint to look at a theorem in your textbook, so you may have to refer to what theorem they're referring here to in the textbook. Okay. So here is another question that was asked to do the velocity. So here you're given the velocity function, right? So keep in mind, if you have the position function, you can get the velocity and the acceleration function. If you have the velocity function, you can get the acceleration function. So when you're asked to find the acceleration, okay, so we know that a as a function of t is the same as v prime of t. Okay? So if you have the acceleration, you can find the velocity. If you have the velocity, you can find the acceleration. Okay? So v of t, so given to you, v of t is equal to 70t over 4t plus 10. So this is a quotient. We'll use the quotient rule. Let's call this h. Let's call this g. So using the quotient rule, v prime of t will be, denominator will be g squared, and g times h prime minus h times g prime. So let's figure out what is h, what is g. So h is 70t, therefore h prime will be 70. Okay, so this is a little side note we'll need. And then g is equal to 4t plus 10. So g prime would be 4. So we can plug that in now. V prime of t is, we need g squared, which is 4t plus 10 quantity squared. Then g, which is 4t plus 10, times the derivative h prime, 70, minus h, which is 70t, times g prime, which is 4. This can be simplified, but since the question is asking me for a specific, so they said for specific time, okay, at 1 second, t was in second here, and round your answer to 2 decimal places. So now, what is v prime when it's 1? So if you want, you could simplify this, or just plug in 1. So it'll be 4 times 1 plus 10. Uh, so this will be 4 times 1 plus 10 times 70 minus 70 times 1 times 4. All of that over 4 times 1 plus 10 squared. So this becomes 4 plus 10 times 70 minus 70 times 1 is 70 times 4 over 4 plus 10 quantity squared. Multiplying the two first, 14 plus 70 will give me 980, and 70 times 4 is 280. 14 squared is 196, and v prime of 1 will be 3.7514 dot dot dot. Your question says to round to 2 decimal places, so v prime of 1 will be 3.5 second, and since they're asking for the velocity here, the unit has to be feet per second squared. So feet per second squared. So it's very important that you write in your units as you solve for these problems. Okay? Now, the next part you will do is when t, because you're still finding the acceleration here, but now t is 5 seconds. And in the third part, you're still finding the acceleration for 10 seconds. So basically the time is increasing, right? What do you expect to see as the acceleration increases? As the time increase, what happens to the acceleration? Right? Will the acceleration be higher or the acceleration be smaller? So something to think about as you plug in those numbers, right? So for your next part, you want to find for part B, this was part A, what is V prime of 5? So you can do that. And then for part C, what is V prime of 10? You can plug in those values into your problem. Okay. So let's try them. So B would be V prime of 5. We know that V prime, we have V prime already. Okay, this is our V prime. So this becomes 4 times 5 plus 10. Okay, remember V prime of t is 4t plus 10. We didn't simplify it. Times 70 minus 70t times 4 over 4t plus 10 squared. So this was what we had from before as our v prime. Okay. So if we plug in 5 there, that's where I'm getting this from, times 70 minus 70 times 5 times 4. Okay. Everything over 4 times 5 plus 10 squared. So this becomes 20 plus 10 times 70 minus 70 times 5. So if we simplify our numbers, we have 30 times 70 minus 350 times 4 over 30 squared. So this becomes 70 times 30 is 2100. 350 times 4 is 1400. 30 squared is 900. And this will be approximately 0.777 continuously. Okay. So V prime 5, the two decimal places, I believe they were asking. Round your answer to two decimal places, yes. So this will be 0.78, okay, feet per second squared. So 0.78 feet per second squared, and that is your answer rounded to two decimal places. Yeah. And then the last part we want to do for part C, when V is, so for part C, what is V prime of 10? So once again, you plug in your numbers, remember the velocity function, so it'll be 4 times 10 plus 10 times 70 minus 70 times 10 times 4 over 4 times 10 plus 10 squared. So that becomes 40 plus 10 times 70 minus 70, 700 times 4 over 40 plus 10 squared. That's equal to 50 times 70 minus 2800 over 50 squared. Then we have 3500 minus 2800 over 2500. So V prime of 10 is equal to two decimal place. If you round this, will be 0.28 feet per second squared. So this will be your results for the third part. So the last problem we'll look at was number 6. So we want to use the position function, okay? So now you're giving the position function. So you're given S of t. And the position function here for S of t is minus 16t squared plus the initial velocity v0 at some time t, okay, plus S of 0 is the initial distance. So you have to know that v0 is your initial velocity and S0 is your initial height. Okay. So the ball is thrown straight down from the top of a building that's 500 feet at an initial velocity of minus 40. So for this problem, the V0 is given. V0, okay, is given to you as minus 40. S0 is given to you as a 500 feet high building. That's where you are. You're on top of the building, so you're 500 feet high. Okay. So S of t, the position function, if you're on top of the building, will be minus 16t squared minus 40t, okay, plus 500 in this example, because this building was 500 feet high. So this is your position function when you're on top of the building. Okay. That's our position function. So the position general function was given to you, okay? And V0 and S0 is given. Now, the second part here is asking you, well, what is V of t? V of t. Well, V of t, okay, is the second derivative of the position function, okay? I'm sorry, V of t is the first derivative. The acceleration will be the second derivative. So V of t is the first derivative of S of t. If you're asked for the acceleration, it's the second derivative. So S prime of t would be minus 32t minus 40 plus 0. Okay, so S prime of t would be minus 32t minus 40. So now you have the first derivative of the position function, but that is the same as the velocity function. So V of t is equal to minus 32t minus 40. And now you have your velocity function. Now, if they had asked you for your acceleration, you take the derivative of the velocity or the second derivative of the position function, okay? But you're asked for the velocity, so that's your function. So for part B, we have to find the average velocity on the interval 1 to 3, okay? We're looking for the average velocity. So we did this problem before, so basically we have to find what is S of t, which we have, okay? S of t we know was minus 16t squared minus 40t plus 500. Yeah. So that's our S of t. And if you're asked to find the average velocity, which is the notation v bar of t, that is equal to S of, if we call this A and we call this B, the formula is S of B minus S of A divided by B minus A. That's our general formula. So first we have to figure out what is S of 3, then you have to figure out what is S of 1. Okay, so those two values you need to figure out what the values are. So if you take a minute and figure that out, so once you figure out what those values are, I believe when I did this here it was 444, and I think when I did S of 3 I got approximately 236.28. So check back these two numbers to make sure they're correct. So this would be T, yeah, just check back those. So then V, the average velocity would be B, as we said, is 3 minus 1. Okay. And then S of B, when we plug in 3, so this becomes 444 minus 236.28. Actually, A, when you plug in A, you get 444, yes. Okay. So your S of B here should be 236.38. And that's your average velocity, which I believe is approximately 103.86. Okay. feet per second squared. So check back the numbers just to make sure on your calculators that they are correct. We go to part C. Part C, you're asked to find the velocities when t is 1 and t is 3. So we did that in the prior example, just a different function, so you know how to do that, right, in this example here. And then find the time in seconds to reach the ground. So that's the position function. So when it's reaching the ground, the function is equal to 0. So basically you're taking, this is for part D, okay, for part D, okay, s of t is given to you, and we know that that becomes, what was it, minus 16 t squared minus 40t plus 500, minus 16 t squared minus 40t plus 500. Set that equal to 0 because that's when the ball will reach the ground, and solve for t, okay, find t. Now, because this is quadratic, you're going to have two different values for t. So ignore negative t's. Okay? And then for part E, find the velocity at impact. So you're basically solving the v of t function, which is minus 32t minus 40, okay, equal to 0. And that will give you your results for part D and part E. I hope this helped you, and let me know if you have any other questions.